So let us continue with part 2, which is still to sketch the graph and to state the domain and range for a function. So we continue with the next type of function, which is the cubic function. Okay, so this is a cubic function where the general expression here is fx equal to ax cubed plus bx squared plus cx plus d. So the highest power for x here is power of 3, a cubic function. So for the domain of a cubic function, fx is defined for all values of x. So we can use all value of x to have the value of y. Thus, the domain of function is real number, means that the domain of f is equal to from negative infinity up to infinity. How about the range? So we consider fx equal to x cubed, then y equal to x cubed. So if y equal to x cubed, then to find the range, we let x as the subject. So we have x equal to y to the power of 1 over 3. So this value of y can be anything from a real number. So it is clear that x is defined for all value of y. Thus, range of function is R, which is the real number where Rf equal to negative infinity to infinity. This R is stating for the real number, okay? It's real number. And Rf here is the range of function f. So, this is the example of function of cubic function fx equal to x cubed. So, how to sketch the graph? For this one, because we have only x cubed, so there will be this shape. It's going up in a curve. It's not a straight line. Straight line is for the linear. This one we have a curve. So positive of x cubed, it will be like this. And then the negative of x cubed is going down. Okay. Moving to the right, the graph is going up for x cubed. But for b, for negative x cubed, moving to the right, the graph is going down. So make sure you remember the basic shape of the cubic function. Based on the graph, we can see that the domain both are from negative infinity to infinity. And then the range also from negative infinity to infinity. So let's do example. Determine the domain and range of the following function and sketch its graph. So now we want to determine the domain and range for each of the function. So for function A, fx equal to x cubed minus 3. So the domain always from negative infinity to infinity. The range also from negative infinity to infinity. So it will be the same for the linear function. So if you notice that the cubic function has the same domain as and range as for the linear function. And then to sketch the graph, what you need to do is just to find the intercept. Okay, x and y intercept. So when x equal to 0, y equal to negative 3. And when y equal to 0, x cubed minus 3 equal to 0. So x cubed equal to 3. So x equal to cube root of 3, which is 1.5. Okay, so the x-intercept here is 1.50. So we have these 2 points. What we need to do is to plot the 2 points and connect the 2 points according to the basic shape of the cubic function. So because it's a positive x squared, here is a positive x squared. So it's going down, moving to the right. So the basic shape will be like this. Okay, so make sure the graph is plotting on the 2 intercepts. Okay, so let's move on to the second example. Okay, so for question number 2, we have fx equal to x squared multiplied by 2 minus x. So to find the domain, it always from negative infinity to infinity. Also for the range, it's from negative infinity to infinity. Okay, to sketch the graph, what we need to do is just to find the x and y intercepts. Okay, so when x equal to 0, y equal to 0, and when y equal to 0, what is the value of x? So x squared multiplied by 2 minus x will be equal to 0. So what is the value of x? X will be 0 and x will be equal to 2. So we have 2 points for the x-intercept, which is 0, 0 and 2, 0. Now what we need to do is just to sketch to plot all the points we have. The first one is 0, 0 and the second one is 2, 0. Okay, because we have the same point for the y and x-intercept. So we have only 2 points. But now to sketch the graph, what we need to do is to make sure we know what is the basic shape of this function. So this is x squared multiplied by 2 minus x is a quadratic, but we need to make sure it's in general form, so we have to expand it. So what we have here is 2x squared minus x cubed. So what is the coefficient for x cubed? We need to know because we need to, yes, basic shape of this graph. We have to determine the basic shape of the graph. So it's an x cubed, so it should be going down. Okay, the graph should be going down. So it's going down, but you need to make sure that it's passed through the point. So this is our graph. Okay. It can be any method lah. So it's going down here and going up again. Oh no. For this one, we cannot going up again. Because why? Because we have only 2 intercepts. So it's going up and going down. If we do as the one earlier, it's going down, up, and then we should have another point. So this shape, if we have 3 points, okay, so this is wrong. So to sketch this graph, because we have only 2 intersects, so it will be going down, up, and down here at the point. Okay, because we have only 2 intercept. Intercepts. Okay, so the next function is a square root function where fx equal to a square root of ax plus b. So we have a function with a square root outside of this. Okay, so how to determine the domain for this type of function? So what we need to do, if everything under the square root should be a positive value. So what it means by positive means that ax plus b should be positive to make sure the fx is defined. If we have a negative value, then we don't have the value for y, because a square root of negative value is a complex number, which is not a real number. Okay, so the domain fx is defined for everything under the surd or square root is more than or equal to 0. That is means by positive. So x should be more than or equal to negative b over a if a is more than 0. Okay, so what we need to do is to find what is x, the interval for x only. Okay, doesn't matter whether a is positive or negative. So if a is a positive more than 0, you get x more than or equal to negative b over a. But if a is less than 0, so you will get the interval for x is less than or equal to negative b over a. So to write down the domain will be different for these two. Okay. Let's say we will see the example later to understand this part. Okay, now rewrite the equation with x in terms of y's for the range. So fx equal to square root of ax plus b, then y is equal to square root of ax plus b, means that y squared is equal to ax plus b, and x equal to y squared minus b over a. So since x is more than or equal to negative b over a, thus, we have y squared minus b over a. The x should be more than negative b over a. So, y squared over a should be more than or equal to 0. So, y squared is more than or equal to 0. So, y is more than or equal to 0. Okay, this working is really long, but we will see how to find it a simpler way. So the range here, it will be 0 to infinity. Okay, so it's not always true, because maybe if we have some extra value d here, then the range will be different. Okay, so let's see some example. Okay, so this is the shortcut that I said earlier. Let's say since this y, square root of ax plus b, always more than or equal to 0. Why? Because we know ax plus b is always more than or equal to 0, means that the square root of both sides will be the same. Means that the square root of ax plus b is more than or equal to square root of 0, which is 0. So what is ax, square root of ax plus b? It's actually the y. Means that the y is always more than or equal to 0. So we can say that the range here is always more than or equal to 0, means that it starts from 0 up to infinity. So this is the shortcut to solve for the range. It will be easier. So let's see some example. So consider the following function, fx equal to set of x. So this is our graph lah. Okay, and then what is the domain for this graph? So how to sketch the graph? Later we'll see. So we have the domain here. We can see that it's only defined from 0 to infinity, and then the range is defined from 0 to infinity. So if we use the function without using the graph, so we can say that everything inside the set, inside the square root, should be positive. So x should be more than or equal to 0. So the domain is from 0 to infinity. How about the range? Since x more than equal to 0, so set of x also more than or equal to set of 0, which is 0. So the y is also more than or equal to 0. That's why we have the range of 0 to infinity. For b, for fx equal to negative of set x, so this is the graph. If we sketch the graph, we get this. Okay, so we can see that from the graph that the domain is from 0 to infinity, and the range is from negative infinity up to 0. So are we going from the bottom to the maximum value of graph here, which is the maximum is here, which is when y equal to 0. Okay, if we use the algebraic method, so everything under the set should be positive. So x should be more than or equal to 0. That's why we have the domain of 0 to infinity. And for y, if we notice, we have to modify to get the function y lah. So we have x more than or equal to 0. So means that set of x also more than or equal to set of 0, which is 0. But the function here has negative. So multiply with negative set x. So will be negative 0. So because it's multiply with a negative 1, so the sign will be changing. That's why we have less than or equal to 0. Means that y should be less than or equal to 0. That's why we have the range from negative infinity up to 0. For this graph, fx equal to set of negative x. Okay, so this is the graph. If we want to sketch the graph, and then to find the domain from the graph, we know that the domain is from negative infinity, and the maximum value here is when x equal to 0. That's why the domain is from negative infinity up to 0. And the range is starting from 0 up to infinity. If you use algebraic method, what we have is everything under the set should be more than or equal to 0. Means that negative x should be more than or equal to 0. So x should be, so we need to multiply with negative 1. So we get less than or equal to 0. Why? Because sign multiply with a negative number, we have to change the sign here. So that's why the domain is from negative infinity up to 0. How about the range? So since negative x is more than or equal to 0, so the square root of negative x is also more than or equal to 0. What is square root of negative x? It's actually the y, more than or equal to 0. That's why we have the domain this. Okay, and the last one, the next one, sorry. So when fx equal to negative of square root of negative x, so we have negative outside the set and negative inside the set. So if see the graph, this is our graph lah. From the graph, we can see that the domain is starting from negative infinity to 0. negative infinity up to 0, and then from negative infinity to 0, so for the range, stop at 0. The highest value for y is 0. Okay, so if we use the algebraic method, so everything under the set should be 0. So negative x more than or equal to 0. This is for domain. So x should be less than or equal to 0. That's why we have this domain. And for range, since negative x is more than or equal to 0, so this is for range, means that the set of negative x is also more than or equal to 0. But because we have negative, we put negative, multiply with negative 1 of negative set of negative x. So we need to change the sign, will be less than or equal to 0. Means that y need to be less than or equal to 0. So this is our range. Okay. Let's do some example, general example. Determine the domain and range for the following function and sketch its graph. Okay, now we have to determine the domain and range first. So for the first question, fx equal to square root of x plus 5. Okay, so how to determine the domain? So fx is defined if everything under the square root is more than or equal to 0. So x plus 5 more than or equal to 0. So x should be from negative 5 to infinity lah. X should be more than or equal to 5. This function only we define if the value of x is more than or equal to negative 5. If it's less than negative 5, let's say negative 6, so what we get inside the bracket, inside the set, we get negative 6 plus 5, which is negative y. And set of negative 1 is not defined. Okay, so that's why our domain is equal to negative 5, from negative 5 to infinity. How about the range? Since x plus 5 is more than or equal to 0, means that the square root of x plus 5 is more than or equal to set 0. So what is set of x plus 5? It's actually our y. So y more than or equal to 0 means that the range is more than or equal to 0. It starts from 0 up to infinity. So now to sketch the graph. So what we need to do, we have the function, we have the domain, we have the range. So the critical point, the main thing here to find is the critical point. So the first step we need to do is sketch x and y axis and then determine the critical point. So how to determine the critical point? You just take the value we have in domain and in the range. Okay, so the critical points here is negative 5 and when y equal to 0. Okay, so the critical point is equal to negative 5, 0. Okay, okay, so this is the critical point. So we draw the critical points on the graph. Locate all the point on x and y axis. So what we have here is negative 5, 0. And then what is the basic shape for this graph? This basic shape of this graph, because it's positive x in positive set, so it's going to right and going up. Okay, because positive x is going to the right and positive set is going up. So that's why the graph here is equal to like this, going to the right and going up. So we have this one point, so connect the 2 points. We assume we have a point here. Okay, so this is our graph because positive x and positive z. Okay, positive x, positive z. So you can look at the, for example, previous. For the second example here, fx equal to square root of 2x plus 4 and then minus with 1. So to find the domain, we have to make sure everything under the set is more than 0. More than or equal to 0. So 2x plus 4 is more than or equal to 0. So x should be more than or equal to negative 2. So the domain here is negative 2 to infinity. And then for the range, we know the square root of 2x plus 4 is more than or equal to 0. To get the y, we need to minus 1. So minus 1 on both sides. So set of 2x plus 4 minus 1 is more than or equal to minus 1, negative 1. So the left side is equal to the y lah. So y is more than or equal to negative 1. So the range is equal to from negative 1 to infinity. And then to sketch the graph, what you need to do is, Yes, to find the critical point. So sketch the x and y axis first. Sketch the x and y axis and then determine the critical point. So we have -2, -1 as the critical point. And then put the points on the axis, on the graph. So it's -2 and -1. This is the point. And then what is the basic shape of the graph? So we have positive x because 2x is positive and positive third, so it's going to the right and up. To the right and up. So this is our graph, going right, going up. We also can see the basic shape from the domain and range because the graph here from -2 to infinity, so it's going to the right, and then the range here from -1 to infinity is going up. Okay, now the next function is reciprocal function. So what is the basic shape of reciprocal function? Fx is equal to 1 over x is the type of reciprocal function. So the domain for this one, we have to make sure everything for the denominator not equal to 0. It's only be defined if the denominator is not equal to 0. So the domain will be everything except for 0. So real except for number of 0. Or we also can write down as -infinity up to 0, not included 0, union width from 0 to infinity. Okay, so this is another method to write down the domain. Okay, so now how about the range? For the range, let y equal to 1 over x, so x is equal to 1 over y. Means that x is only defined when y is not equal to 0. So it's the same as the domain, which is it's a real number except for 0, or from -infinity up to 0, union with 0 to infinity, where 0 is not included. Okay, so how to sketch the graph of this type of function? So we have basic shape of 1 over x graph. It will be, because we cannot include 0, and then here also we cannot include 0 for the range. So when x approach to infinity, so what is the y? Y will approach. So let's say x equal to 10,000. So y will be really small. So it's going to be small when it's going to infinity, to the right. And when x is really close to 0. Okay. So we are going to look at the range of 0, the domain of 0 to infinity. So when x approaching to 0, so we take, let's say, 0.0001. So y will be really big. So connect these 2 points. This is a point, 10,000 and 0.001. And this one is 0.0001 and 10,000. So it will be a point here and here. Okay. So for the other side of domain, from -infinity to 0, so when x is approaching to -infinity, for example, -10,000, y will be -0.0001. It's really small, nearing to 0. And then when x is equal to -0.001 and y equal to -10,000, so it will be these 2 points. So one point is here, -10,000 will be on the left side of the graph, and y is really approaching to 0. So it will be here. And then when x approach to -0.01 will be around here. So the y will be really big to the bottom. Negative, right? So it will be here. So the graph will be like this. Okay? So this is the basic shape of the graph of a reciprocal. Okay? Okay. Do we need to do this every time? No, we just have to know the basic shape of the 1 over x graph. How about the negative of 1 over x? So the domain will be the same. It's only defined when the denominator is not equal to 0. So here x is not equal to 0. So range, the domain will be everything except for 0. And the range, let y equal to negative 1 over x. So x equal to negative 1 over y. So y not equal to 0 is the same as the previous example. So now to sketch the graph. So for the domain of negative infinity to 0, union with 0 to infinity, let's say we take the first half here. So when x approach to infinity, let's say 10,000, the y will be negative 0.0001. So for x is small, nearing to 0, so we have these 2 points. So if we plot this graph, so 10,000 is negative 0.01, so it will be here. And then here is 0.01x and negative 10,000 is going down here. Okay. And then for the other domain, this side of domain, when x approach to negative infinity, y will be 0.001, negative 0.01. And then when x equal to really small, nearing to 0 from the left side, so we have the value of y equal to positive. Oh, so it should be this other side lah. Sorry, it's positive here. So negative x and positive y. Here is negative but positive 10,000. So this is our basic shape of the graph after we plot and connect the points. So this is the graph for the reciprocal when the coefficient of the reciprocal is equal to negative. Okay? Okay, so the next one, basic shape of function for absolute value function. So we learned already what is an absolute function, absolute value, absolute equation and absolute inequality. So function also the same, but we have fx in front of it. So fx is equal to absolute of ax plus b. So how to find the domain? Domain will be from negative infinity to infinity always, because it's just a combination between linears. Okay, so how about the range? So we have to define this absolute function. So let y equal to absolute of ax plus b. So this is what we apply from the chapter 1, chapter 2. So what we do is to define the ax plus b. So this value is always more than or equal to 0, right? Why? Because we cannot have negative inside the absolute notation. So that's why ax plus b, absolute of ax plus b more than or equal to 0, we use the definition of absolute inequality. So we have ax plus b more than or equal to 0. And this is actually our y. Okay, so y is more than or equal to 0. Okay, remember that everything inside the absolute should be always more than or equal to 0. So the range here is from 0 to infinity. How to sketch the graph? Note that the definition of ax plus b is the same as the one we learned in chapter 2. So if ax plus b, it will be ax plus b when ax plus b is more than or equal to 0. Why? It's positive here and it's positive outside the bracket. Okay, that's why ax plus b should be more than or equal to 0 to have the positive value inside the bracket. And then the second one is negative for ax plus b equal to negative. So ax plus b is less than 0 lah for the domain. Why? Because negative multiplied with negative, we will get positive value. Absolute will be always positive. So the graph will be for ax plus b more than or equal to 0. And for the ax plus b is less than or equal to 0. So actually it should be ax plus b. X is more than or equal to negative b over a lah. This value here should be negative b over a. We can see that the domain always from negative infinity to infinity and the range is from 0 to infinity. So let's do some example. Determine the domain and range of the following function and sketch its graph. Okay, so function f(x) equal to absolute of x minus 2. So to find the domain, it's always negative infinity to infinity. The range, because we know that absolute of x minus 2 always positive, so y also more than or equal to 0, always positive. So the range equal to from 0 to infinity. And then sketch the graph. So what we need to do, sketch the x and y axis and then determine the turning point, the vertex. What is the the turning point? So we just have to find when x minus 2 equal to 0. So x minus 2 equal to 0, so x equal to 2 is the x coordinate of the vertex. So when x equal to 2, y equal to 0. So 2, 0 will be the turning point, the vertex. So we plot the turning point on the x and y axis and sketch the V shape. So because we have a positive value in front of the absolute, so we will have a V shape like this. Okay? So it's going up and up on both sides, left side of 2 and right side of 2. Okay, so let's do this example. So f(x) equal to absolute 1 minus x minus 3. So the domain here is always negative infinity to infinity. How about the range? So because absolute 1 minus x is always positive, so if we minus the negative 3, so absolute 1 minus x minus 3 on both sides, we have absolute of 1 minus x minus 3 is more than or equal to negative 3. So the left side is actually our y. So y must be always more than or equal to negative 3. So the range is starting from negative 3 to infinity. And then the next step what we need to do is to sketch the graph. Okay, so how to sketch the graph? We just have to sketch x and y axis and find the vertex. So what is the vertex? When everything inside the absolute equal to 0. So 1 minus x equal to 0, so x equal to 1. So when x equal to 1, y equal to negative 3. So the point here is 1, negative 3. So plot the point on the graph and then draw the V shape. So because it's positive absolute, so it will be going up like that. Okay. Okay. So let's continue with the next type of function. Oh, after that, don't forget to find all the intercept on the graph. So here, when x equal to 0, we have y equal to negative 3. So 0, negative 2. So when x equal to 0, y equal to 1 minus 0 minus 3. So 1 minus 3 is negative 2. Fine for this one also. Okay. Okay, so let's move on to some facts that we need to understand before we continue. So, if f and g are two functions with domain df and dg respectively, then the addition between these two functions will resulting on the intersection between the domain. Okay? And for subtraction also the same. So, we will find out the domain of this subtraction between two functions. Actually, the intersection between the function respectively, the domain of the function respectively. So we have to find the intersection between the domain of the function and to find a new domain for the subtraction between the two functions. The same as the multiplication between the two functions. So we have to find the intersect. And for the last one, the division between the two functions, the domain is also the same, which is we find the intersection between the domain of function f and the domain of function g. But we need to subtract with the value of x where the gx is equal to 0. Why? Because we have to make sure that the denominator must not equal to 0. Okay, so this is really important for you to determine between the addition, subtraction, multiplication, and division of functions. Okay, so let's do example 6. So given the f(x) is equal to x minus 4, gx equal to x squared minus x, and rx equal to square root of x minus 3, find f plus g and its domain. So what is f plus g? So we add up the function of f and g. So what is f? F is x minus 4. What is g? X squared minus x. So domain for each function, if we find out respectively, fx will have domain for f, it will be negative infinity to infinity. How about gx? The domain also will be from negative infinity up to infinity. Okay, so the domain for the r is everything inside the set should be more than or equal to 0. So x minus 3 is more than or equal to 0. So x should be more than or equal to 3. So the domain is from 3 to infinity. So now we have the domain for each function. So to solve the question, for the first one, the addition between f and g. So what is function f? X minus 4 plus with x squared minus x. So the function here will be x squared plus minus 4. Okay, so this is the new function, the addition between f and g. How about domain? We just need to find the intersection between domain f and domain g. So both are negative infinity to infinity. So the intersection will be negative infinity to infinity. Okay, so the next question is for f minus r function. So f function is x minus 4 and r function is square root of x minus 3. So subtract between these two functions. So we cannot do anything more. So this is the results for f minus r function. And then the domain between this function, we need to find the intersection. For the f function, it's from negative infinity to infinity. For r function, it's from 3 to infinity. So where is the intersection? The intersection is from 3 to infinity. So the domain for this f minus r function is equal to from 3 to infinity. Okay, the next one, for f multiplied with g function, so x minus x multiplied with x squared minus x function. So we have x cubed minus 4x squared minus x squared plus 4x will be x squared minus 5x squared plus 4x. So what is the domain for this function? So f multiplied by g will be the same, the intersection between domain f and g, which is we found out already in part A, question A. So the answer should be negative infinity to infinity. Okay, so why we need to know these facts? Because we have to know that to apply in the piecewise function. Okay, what is piecewise function? So piecewise function is a function which is defined by different expression for different parts of its domains. So the range of the function is easier to be determined by its graph. So to determine the range of the piecewise function, we have to sketch the graph lah. So let's see the example, directly the example. Sketch the graph of the following functions. Hence, find its domain and range. So if you notice here, we have this brace bracket. Okay, so this function fx is separated into two functions. The first one is x plus 1. For the value of x, the domain from negative 1 to 0. And the second function for this fx is, the second part is negative x plus 1 if the x is from 0 to 1. Okay. Okay, so let's see how to solve for this type of question. We want to sketch the first graph first. So for question A, so what we need to do is to separate into two parts of the domain and sketch the x and y axis and label all the points. Okay, determine the endpoints for each function. So for at negative 1 to 0 for the first function, so the endpoint when x equal to negative 1, y equal to, substitute the negative 1 into the function, so we have y equal to 0. And when x equal to 0, the other end of the limit is y equal to 1. So we have these two endpoints. And then for the next intervals from 0 to 1, so we substitute x equal to 0 and x equal to 1 into the function. So when x equal to 0, y equal to 1. And when x equal to 1, y equal to 0. Okay, so now we have all these 4 points. So connect the 2 points, all the 4 points separately. Okay, so locate all the points on x and y axis and sketch the graph. So now we have all the 4 points, and this is our x and y axis. So plot all the 4 points for the first intervals. So we have negative 1, 0 and 0, 1. So locate all these 2 points. So this is negative 1, 0 and 0, 1. So because it's a linear, this is a linear, right? So it's just a straight line. So connect the 2 points using your ruler. So we have the first part of the piecewise function. And then the second part of the piecewise function, we have 2 points, 0, 1 and 1, 0. So connect these 2 points. So since it's also a linear function, this is type of linear function. So it's just a straight line. So connect the 2 points directly. So we have this graph. So now this is the graph because we don't have any value of x in other part. So we have only from negative 1 up to 1. So this is all of it. So now to determine the domain and range, we just look at the graph that we have sketched. So what is the value of x? We can see that the x is only defined from negative 1 up to 1. So we don't have any other value of x. It's only from negative 1 to 1. So the domain is from negative 1 up to 1. Both are included. And for the range, if we see the value of y, so it's only starting from 0 up to 1. So that's why our range is 0 to 1. Both are included. Okay, so now let's do question B. So we have these 3 functions in different domain. So determine the endpoint for each function. Okay, so now we have endpoint negative 1 and 1 for function x, 1 and 2 for function 2, and 2 only for function x squared. Okay, so let's find the endpoint for each function. For negative 1 and 1, when x equal to negative 1 and 1, y equal to negative 1 and 1 because it's function x, right? So directly it's a point of negative 1, 1 and 1. 1, 1. And then for the second part, for interval 1 to 2, so we have a function x for x equal to 1, x equal to 2. The function y is equal to 2. So this is the constant function. So it always be 2 whenever the value of x is. Okay, and the last one, x squared. So when x is more than 2. Okay, so when x equal to 2, what is the value of y? It will be 2 squared, which is equal to 4. So the point is 2, 4. Okay, now we have all these 5 points. Point 5, the last one is only have 1 endpoints. So now, so what we need to do is to plot all of these points respectively. So for the first interval, so we have from negative 1 to 1, we have 2 points, which is negative 1, 1 and 1, 1. Okay, so now because x is a linear, right? So because it's a linear, so it will be a straight line. This is a linear, so we just connect these 2 points, so we have a straight line here. And then for the second interval, from 1 to 2, so x is 1 and 2. So all the value here is 2. So we connect these 2 points, it should be an horizontal line. So it should be here, horizontal line. Okay, and then the last one is when x is more than 2, so the value at x equal to 2 is 4. Y is equal to 4. So because it's a quadratic and then it's a small quadratic, so it should be positive x squared. So it should be going up. So this is our graph is going up at 2, 4. Okay. So from the graph above, we can determine the domain and range. So what is the domain? So if we see the domain here is starting from negative 1 up to 1 and then continue in the second interval from 1 to 2. So if you notice at 1 here for the first interval it's empty dot. Why empty dot? Because it's not included in the interval. Okay, make sure you put empty dot, a circle. And then for the second interval is starting at 1 up to 2. So we have the value of x here where x equal to 1 and then continue when x is more than 2. Also this is an empty dot, a circle. Why? Because 2 is not included. Okay, so the 1 and 2 is on the second interval only, but we have all the value of x from negative 1 up to infinity. This graph is going to infinity, so that's why the domain is from negative 1 up to infinity. How about the range? Okay, so if we see the range, the lowest value of y is here, -1, and that is stopped at 0 at 1, but 1 here is not included. Okay, right? That's why it's -1 up to 1, where 1 not included, -1 included. But the next one, we don't have value y in the graph. The next value we have is 2. So that's why we have 2 only, and it stopped at 2 and then continue starting from 4 up to, it's going up, so up to infinity. That's why our range will be a combination between all of these interval, which is -1 up to 1, where 1 must not included, union with 2 only, an element of 2, and then union with 4 to infinity. Okay, so that's why we need to sketch the graph to find the range. So it will be tricky. Okay, so that's all for these 5 type of function, except for the linear and quadratic. So it will be trickier for you. So you have to do on your own, to try to do on your own to find the domain, range, and the sketching of the graph. Okay, so that's all for this lecture 1. Thank you.